Hi guys, a very good day to everyone, and welcome back to Budget Power Electrical Solutions, understanding real electrical systems. We'll look at what the symbol means, how it works, and where it is used in practical applications. So stay with me until the end, and don't forget to subscribe. Give this video a thumbs up and leave your comments below. Alright, let's get started. Now let's look at symbol number 11. You will often see this symbol in motor control and industrial electrical drawings. Do you know what it represents? This is a contactor coil. Its terminals are normally marked A1 and A2. When voltage is applied, the coil creates a magnetic field that operates the contactor and changes the state of its contacts. In a motor control circuit, pressing the start button energizes the KM1 contactor coil. The contactor closes its main power contacts and the motor starts. When the coil is de-energized, the contacts open and the motor stops. So remember, coil energized, contactor operates, load runs. Now let's look at symbol number 12. You will commonly see this symbol in motor starter and protection circuits. Do you know what it represents? This is a thermal overload relay. It protects the motor from sustained overload current. During normal operation, 95 to 96 is normally closed and 97 to 98 is normally open. When an overload occurs, the relay trips. 95 to 96 opens to stop the motor, while 97 to 98 closes and can provide a trip or alarm signal. In a motor starter circuit, excessive motor current causes the overload relay to trip. 95 to 96 opens, the KM1 coil de-energizes, the contactor opens, and the motor stops. At the same time, 97 to 98 can close to indicate that an overload trip has occurred. Remember, overload relay trips. 95 to 96 opens, motor stops. 97 to 98 closes, trip indication. Now let's look at symbol number 13. You will often see this symbol in pump, compressor, and industrial control circuits. Do you know what it represents? This is a pressure switch. It detects pressure and changes the state of its electrical contacts when the set pressure is reached. Depending on the circuit, the contact may be normally open or normally closed. In this pump control example, when the pressure falls below the set point, the pressure switch changes its contact state and sends an on and off signal to the PLC or control circuit. The PLC can then energize the KM1 contactor and start the pump. When the required pressure is restored, the switch changes state again. Remember, a pressure switch gives a discrete on and off signal. If we need continuous pressure measurement, we normally use a pressure transmitter, which can provide signals such as 4 to 20 milliamperes or 0 to 10 volts. Now let's look at symbol number 14. You will often see this symbol in pump systems, HVAC, chillers, and industrial control circuits. Do you know what it represents? This is a flow switch. It detects whether fluid is flowing and changes the state of its contact when flow starts or stops. It is commonly used for proof of flow, interlocking, and dry run protection. In this example, when the pump starts and water begins to flow, the flow switch changes its contact state. This provides a digital on-off signal to the PLC, represented as logic 1 or logic 0. For example, with a normally open contact, flow can close the contact and the PLC input becomes 1, on. If flow is lost, the contact opens and the PLC input becomes 0, off. The PLC can then confirm proof of flow, continue the process, or stop the equipment and activate an alarm if flow is lost. Remember, flow detected digital signal changes PLC confirms flow equipment operates safely. Now let's look at symbol number 15. You will often see this symbol in tanks, some pumps, water systems, and control circuits. Do you know what it represents? This is a float or level switch. It detects the liquid level and changes the state of its contact when the float moves. It usually gives a digital on-off signal, which the PLC reads as logic 1 or logic 0. Depending on the application, it can be normally open or normally closed. In this example, as the tank level rises, the float moves and the level switch changes state. That sends a digital signal to the PLC or control circuit. The PLC reads it as 1 or 0 and then starts or stops the pump or activates an alarm. Remember, level changes switch changes state, PLC sees digital 1 or 0 control circuit operates. Now let's look at symbol number 16. You will often see this symbol in heaters, fans, HVAC systems, motors, and protection circuits. Do you know what it represents? This is a temperature switch. It detects temperature and changes the state of its contact when the set temperature is reached. The contact can be normally open or normally closed. It provides a digital on-off signal, which the PLC reads as logic 1 or logic 0. In this example, when the temperature rises above the set point, the temperature switch changes state. That sends a digital signal to the PLC input or control circuit. The PLC reads it as 1 or 0, and then it can start a fan, stop a heater, or activate an alarm. Remember, a temperature switch gives a digital on-off signal. If continuous temperature measurement is needed, we use a temperature transmitter, which provides an analog signal, commonly 4 to 20 milliamperes or 0 to 10 volts. So remember, temperature changes switch changes state PLC sees 1 or 0 control circuit operates. Now let's look at symbol number 17. You will often see this symbol in metering, motor control, and protection circuits. Do you know what it represents? This is a current transformer, or CT. It reduces a large AC current to a smaller proportional secondary current, commonly 5 amps or 1 amp. The CT ratio is very important. For example, a 200 to 5 amp CT has a ratio of 40 to 1. So when 200 amps flows in the primary, the secondary provides 5 amps. This signal is then used by ammeters, power meters, and protection relays. In this example, load current flows through the CT primary conductor. The CT produces a proportional secondary current according to its ratio and sends it to the meter or protection relay. If abnormal current is detected, the protection relay can operate a trip or alarm. And remember this important safety rule: never open circuit a CT secondary while the primary is energized. Here is symbol 18. Do you know what this electrical symbol represents? Take a few seconds and think about your answer. The answer is a voltage transformer, also called a potential transformer, or simply VT or PT. Its purpose is to step high AC voltage down to a safer, proportional voltage that can be used for metering and protection. For example, if we have 600 volts on the primary and 120 volts on the secondary, the transformer ratio is 5 to 1. Remember, the ratio is very important because the measured secondary voltage represents the actual system voltage. Now let's look at the practical application. Here, 13.8 kV is connected to the primary of the VT/PT, and the transformer steps it down to a proportional secondary voltage, such as 120 volts, for meters and protection relays. Both the primary and secondary sides are properly fused, and the secondary circuit is correctly grounded for safe operation. When selecting a VT and PT, we must check the voltage rating, ratio, burden, accuracy class, and insulation rating. So remember, correct selection, proper fusing, and grounding are essential for safe and accurate VT and PT operation. Thank you for watching Budget Power Electrical Solutions. If this lesson was helpful, don't forget to give it a thumbs up, subscribe to the channel, and leave your comments below. Keep learning, keep improving, and remember, learn today, power tomorrow. I'll see you in the next electrical lesson.